Well, hello friends. Today we are going to work on profiler stuff. So a feature that I wanted for a long time and I just never get around to making is when I'm looking at something in the system monitor and it's using a bunch of CPU, I wish that I could just right-click on it and start profiling it. Wouldn't that be nice? And that's what we're going to do today. So basically, we're going to make it so that you can start profiling and it will create a profile, run for a while. We're currently a bit limited on how long we can profile, but we'll profile as long as possible and maybe have a GUI that allows you to stop it, and then it will bring up the profile viewer for you. So I guess let's just get started. So the first thing we're going to do is we're going to start by turning the profile viewer into the profiler program. It's something I've been meaning to do for a long time because it's really not meant to just be a viewer, it's meant to be a complete profiler. So we'll just rename it profiler, and I'm sure that I have to tweak that in a place or two. So profile viewer becomes profiler here. Okay, some very exciting changes here. And finally in the build root file system. All right, so starting out with a very simple change, and maybe we'll keep the old name PV because I'm so used to typing it for the shorthand. So profiler, rename from profile viewer. Okay, so then the let's just actually verify that everything still builds, but I don't see why it wouldn't. And then I guess I still have a mounted file system here. Let me see if I can get rid of that. All right, so let's get started. Profiler main. So first thing we want to do is we want to be able to launch profiler without context. So currently you can only launch it by specifying a path to a profile. So the way it works right now is that you would profile something like a command like ls-l, like this, and then you would have a profile show up in proc profile. So it's right here. You would run profile viewer or now profiler on it, and then it opens up like this. What we want is we want to be able to just start the profiler, and if you don't specify a profile path, then it will pop something up and ask you, I guess, which running application would you like to profile? Alternatively, would you like to specify a command to profile? That would be pretty cool. So let's add that, and I guess actually maybe we should only have we can do only selecting one of the running apps as the initial thing, because if you want to profile a specific command, you can just use the command line profile command right now anyway. It's already so streamlined. But in the DevTools profiler, so let's make something new here, like a list of running processes that you can select from. So maybe like running process model, and we will put those in a combo box or something. Maybe in a table view. Maybe a combo box would be the nicest. PQRST, running profile model. All right. So let's go and implement that model. Running process model, sorry. Oh, did I type the wrong thing? Yes, I did. I meant to say running process model. It's going to be a model that basically just has a list of all the running processes on the system so that you can select one. To to run the profiling stuff on. So pragma wants, and this will be, I guess we'll just grab the GUI model. This is what I normally do. I just grab all of the pure virtuals right here. And then go to town with model. I have not written a model class in quite a while, so this will be class running process model. Actually, maybe this should be running processes model. Dang it, yeah, that's a better name. Well, better change it now before it gets all tangled up. All right. Sure. And we're back on track. All right. So this guy is going to inherit from GUI model. And let's add some GUI : to these guys. Oops. And I think we don't need the default arguments here. So what do we care about here? I guess we care about the PID and the process name. Probably the UID, because we're only going to be able to profile things that we have access to. So things that are running as our UID, or if we're a super user, we can profile anything. But I think it would make sense to at the very least, we would gray out stuff that we can't profile. So let's see. It's an abstract class. What am I missing? Is it a destructor? No. Well, oh, right, because I didn't make these concrete or whatever the opposite of abstract is. Okay. And to implement this class, we need to fetch all of the running processes, obviously, which will be pretty easy because we have a utility class for that in libcore called process statistics reader. So we can just go and yoink that, and using a pound yoink, and it will do all of this good stuff for us. So let me just instantiate some member functions here, and we'll put that down in the privato section, and we will make one of those guys. Create. All right. I'm just doing all of the boilerplate business. Okay, here we go. Now we are finally cooking. So when we update this model, we want to populate it with all of the processes currently running on the system. So what we'll do is we will create a core process statistics reader, and reader will get all. Okay. Processes. Okay, and then for auto process in processes, and then what we want to do is we want to have some kind of a struct here that we collect a bunch of. So we can call it maybe like process info or something like that. Maybe even process for that matter. We can just have a vector of process. Okay, and then the things we care about here are essentially the PID and the name and the UID. And maybe the icon if it's a GUI app, actually. So the icon, The icon would be a shared buffer that we would have to go and pick up. We'll figure that out. So let me just mark these overrides so that we actually know that we have to override them. Good. And then I think, okay, so then here what we'll do is we'll say like process, ppid is process pid, p name is, wait. What is in that thing? Oh, shit, right. It's keyed on the PID, so it's actually an iterator, not the process. Okay, so then we can call this process. That's a nicer fit anyway. Okay, so it value PID, a value name, and the UID is it value UID. All right, and there's a whole bunch of stuff we don't care about. But I think we do care about the icon. So process icon is it value icon id, and the icon id refers to a shared buffer. So the way global app icons work in the system is that you actually register with the kernel when at runtime. You register a shared buffer ID that contains a bitmap for your application icon. And it is, I think it's assumed to be a 16 by 16 RGBA 32-bit icon, essentially. And then that's used by stuff like taskbar and system monitor. So I think, let's see how system monitor picks that up. You will do a share buffer create from shbuffed. Oh, this actually looks pretty chunky. Could probably do less of this and make system monitor use way less CPU for its updates. But anyway, this is essentially what we want to do. So we want to create a shared buffer attaching to that icon. So instead of storing the icon ID here, let's set a good example for the future and store a graphics bitmap directly, because then we don't need to refetch it. Bitmap. It's nice when you have to redo something that you've done before, but in kind of a different context, because then you tend to do it better than you did last time. At least I do. And then if you're diligent about it, then you can go and make that older code better later with what you learned, maybe even share some code. So here I'm noticing, I'm reading this stuff now and it bothers me how stupid it is. So I'm definitely going to go through here later and make this nicer. And the reason that it's stupid is just because every time we update the screen in the system monitor app, we refetch we reattach to the icon of each application that has one. So if we look here, like this, we have a few running apps with icons, right? Like we have the terminal and system monitor. If I start file manager, we'll have some more. Browser, we have some more. And every 1 second when this app updates, it will like reattach to the shared buffer and disconnect and reattach, and it's just silly. Anyway, enough about that. Let's just do it in a nice way here, and then we'll learn from it. So if it value icon ID is not -1, I think that is the code for na. Maybe we can say if it's greater than 0, or you know what, let's go look it up. What is the default value? Come on, man. Okay, so what is m icon ID in the kernel? It is -1 if you didn't have one set. Okay. So if it's not -1, then let's try to attach. So we will do shared buffer, yeah, we need shared buffer. Create from shbuffed it value icon id. If this works, so if this then process.icon is graphics bitmap create with shared buffer icon buffer. Oh wait, we have to specify the format. So that's a graphics bitmap format. RGB 32, and it's a 16 by 16 bitmap. All right, so that's pretty cool. Of course, if this fails, we'll just return null, and then this will be null, and it will be good. Okay, so that's pretty okay. And then I guess when we start this whole procedure here, we'll do mProcesses clear in case this is not our first update. And then mProcesses append move process. All right. So far, so good. So now, how many entries are in this model? We have to answer a few questions here. So these are the typical questions that will be asked. And let's go and implement those. So we have the row count. How many rows are in this model? That is very easy to answer because the number of rows is just how many processes do we have in our vector. And the number of columns, that's essentially how many different columns do we want to have. I think we have PID, UID, name, and icon, right? So that's 4, but let's put that in an enum, so we'll have something like this instead. And then we'll do like enum class column count. So we'll have PID, UID, icon, and name, and we'll maybe put the icon first. Yeah, that's better. So, oh, dang it. All right, fine, let's use plain enum. Be that way. Okay, and finally the data callback, which is where we actually fetch information for the caller. So here we need the index and we need the role. Okay, so the process is going to be the mProcesses at index row. And then we can just say if role is role, wait, what's the name? Role display. This is what we should show here. So depending on the column, case column PID, then we will display process PID. So this is pretty straightforward. I guess this is turning it into a table view. I guess that's what we'll have to use. Originally I was thinking we could use a combo box, but a combo box isn't going to support multiple columns of things. It might be nice in the future to have like a combo box that could support an icon for each item. And I don't know if columns make sense in a combo box. Do people do that? Let's do a quick survey. Combo box columns. It looks a little bit outlandish, but I don't hate it. It's just a little bit weird. I don't know if I'm getting only results, only Windows screenshots because I'm Googling on Bing, or because I need to go and Bing on Google as well to see. All right. Maybe this is like a Windows paradigm. Anyway, let's not worry too much about that. So for icon, we need to return a GUI icon, I think. How do we construct these things? I don't remember. Just give it a bitmap. Okay. So There we go. Okay. And finally, we also had the name, process name. So actually, if the process has no icon, then it's an empty value. No icon for you, dude. All right. And here we'll just assert reached because we don't have any other columns, so we should never get called for anything else. And I don't know if I'm forgetting something, so I guess we can just start like this. That's pretty good. Should we sort this maybe? We sort by PID or by name, or we could make it sortable. We could allow you to sort it actually yourself. I don't know. We don't have to figure everything out at once. Okay, so anyway, let's throw this thing into a table view so that we can actually use it. So let's see. So here we fail immediately if we don't have a file specified, but instead of failing, we will go to we'll run in a different mode. So how do we do that? I guess we toss up a dialog, and at the end of this process, by the way, the path that we want to run is going to be the default profile output path. So we'll put that up here. Null patr. All right, and then instead of returning, we'll just say path is proc profile. So the whole proc profile thing is not permanent. It's just a temporary way that we've solved this. So you'll be able to communicate like a huge, what's essentially a huge JSON file from the kernel to user space. But there are all kinds of limitations because of this way we are exchanging data. So it has to change in the future. But right now it's going to work for what we need. So let's see. So let's throw up a window here. So we'll just make a window is GUI window construct. And I guess we will put a widget in that. So just a basic should we have buttons and stuff? I guess we could have some buttons. So let's make a plain widget here. Set main widget, just a plain GUI widget. All right. And then we will set a layout on it, and it will be a simple vertical box layout, I think. That'll be fine. And we will put a table view up top. So table view is widget, add a GUI table view. And maybe we'll add a button, like something to hold some buttons below the table view. So button container can be widget, add GUI separate widget. Maybe we'll put something in the table view also, like set model. And then we need to have one of those running process model things that we were creating. So this guy right here, oops. And we will make a profiler running process model create. Okay. And then button container, set a layout on him. How about a horizontal box layout? Maybe he will have a size. Maybe he'll be like, I don't know, 30 pixels tall, something like that. And maybe we'll stretch or fill the size horizontally, but vertically we'll fix it. Should add some more size policies and GUI layout stuff eventually. It's a little bit limiting sometimes, I feel. But at the same time, it is amazing how many basic layouts you can create with just with just 2 axes, fill and fix. So okay, so that's pretty good. And then let's just slap some buttons in there, maybe 1 or 2. So run or profile button, button container, add GUI button profile. And we will also have a cancel button if you change your mind and you don't want to be part of this whole thing anymore. And on cancel button, oh, we need to include. On the cancel button, if you click on that, you know what we'll do? We will just say, fine, no big deal, we'll just leave. We'll leave big time. And if you choose profile, then we will what do we want to do here? I guess we want to run the profile command on this process, or really what we want to do is like we want to make a syscall here. So we have in the serenity.h header profiling enable for the PID that you have selected. So at this point we need to know what PID you've selected, and I guess we'll know that by querying the model. So how do we say table view dot selection dot first, or wait, if table view selection is, if the selection is empty, right? If the selection is empty, then this is not going to work. So we'll do a GUI message box show no process selected. And then we will need GUI message box for that, of course. And GUI message box type, I suppose that's an error. GUI message box input type. Really, you can only say OK to that, and we will pass the window just to center it nicely. And then after that returns, we will just return from the onClick handler, and then you can have a chance to do better. But if we do have a selection, then that would be the first index of the selection, and we need to go and ask the model. So we would query the table view model data at index role. We will ask for what's the custom. Custom is the name, yes. And actually, we need to make specifically request the. We want specifically the PID. So, I mean, I guess we can just hack it using the custom role. So, yeah, let's just use the custom role. So the running process model here, essentially now we're calling data, but with a different role. So we'll say if role is custom. This is never, the custom role is never called by standard GUI widgets. It's just for your app to use for implementing any kind of lookup or whatever you might need. So if you query the custom role for any row at any column, we ignore the column part here and just always return the process PID. Yeah. So then we know that we have the PID variant as a variant. So then we can assert PID as variant is I32, and then And then PID is PID as variant si32. I mean, I guess we can just do that right away because I think this will assert for us. Yes. And then we'll try to profiling enable. So if this fails, we will show unable to profile. Let's see. So PID, and then we will also show the error. So that'll be PID and stutter error. Saved error now. Okay, this line is going to get a bit long, but that's okay. It's not the end of the world, and I guess we need string.h for stir error. All right, and there we go. And then outside of that, I guess if we get here, this means that we have succeeded. So we should really like bail out of the event loop so that we can continue, because my intention now is to start an event loop here. Really, we would do this. This is a little bit unusual. Like we start the application up top, and then we run the app event loop once, and then it will exit from the event loop successfully, and then we will just continue running, and then basically we'll start the event loop all over again later on after we create the normal UI. This is a little weird, a little awkward, but let's just roll with it. So here, what we need to say is app for event loop current. No, how do I get to him? Incomplete type. Oh. Libcore event loop. I just want to talk to the event loop, dude. Current quit. Yeah, because I don't want to quit the whole app. I just want to quit the current event loop. And then I cannot do this that I'm trying to do. Wait, why not? On click. Oh, it gets the modifiers. Oh, right. So actually, yeah, let's just do auto. And it should be the same for the other guy, right? So here. Oh, in the running processes model at 103, here we need to just return something if you get a strange request for some role that we don't implement. Oh, maybe I should show that window that I created before we go into the event loop. So window show. Maybe we should also set a title on it. It's a little not nice to not set a title. Profiler. Should we also set a rect, perhaps? Or we can resize it to a size. How about 480 by 360? Fancy size. Maybe we'll even center it on screen. Wouldn't that be something? GUI desktop the rect. So rect, and the rect is, wait, how do you do this? I I haven't centered something on screen for a while. We should probably have a nicer way of doing that, by the way. So right now what we'll do is this, and then we'll like call center within. So window rect center within the desktop rect, and then we will do window set rect, window rect. Yeah, because that's a little bit awkward. Like, it would be nice if there was a way to say, make me this size and put me center screen. Okay, so this UI, beautiful, right? Missing a few things. So it needs to have some background color here because it looks stupid with the black. So let's just say widget set fill with background color true. And then I am missing data in here, so I guess why are we missing all the data? Are we not calling update on the model, perhaps? Maybe I have to do that myself. I always forget this type of stuff. Table view, model, update. The way I remember, the view is supposed to update the model, but maybe it doesn't do that. Oh, look at that, we have an icon. But then, oh, everything, only the icon works? That's a bit funny. Okay, so what the heck? So the terminal icon showed up, so at least we are doing something right. Running processes model. Oh, wait, we need to name the columns. Column name. So it's supposed to be a string? Yes, that's the API. We have to name the columns, otherwise they look silly. So running processes model column name. Okay, and then we have our cases. So this one we can actually, let's not name that icon one, it doesn't matter anyway. And then this one we call PID, UID, and name. And then we can assert not reached here, okay. And I guess we should set that thing so that it auto sizes the columns. So let's do that right away. Table view set. I always forget what this thing's called. Okay, I have to go look at the, what is it called? To fit content something? Columns. Okay, this API name is clearly bad because I can't remember it. Normally I can remember all the API names. But I can't for the life of me remember what the auto-sizing API is called. Wait, maybe I removed it because we always auto-size. I think that's actually that's actually what we did. That's fine. Okay, so well then it's good that I don't remember it because it's not there. Okay. So you guys should actually, it's auto-sizing to the column name, but it's not auto-sizing to the whole thing. And also, did I need that update call? Just verifying here. Yes, I did. Okay, so the update needs to be there, but table view, you need to update column sizes. Who does this? Who? Did update model calls update column sizes? Sure. And then it will iterate through all of the columns and measure them. Also, we should probably make this thing sortable. So let's put a sort proxy model on there. Sorting proxy model. Table view. So instead of setting this model, we will do a GUI sorting proxy model create. We'll just wrap it like that. This did not work the way I had hoped. What on earth? Maybe I'm not remembering how to do anything. Let's see. What do we normally do with this type of stuff? It's good that I'm using this. It's been so long, so it's really good to mess around with some stuff like this. So we need to call set key column and sort order to set that up. And then, okay, so table view model set key column and sort order. Sure. So we set the key column to profiler running process model column PID maybe. Sort GUI sort order ascending. Or maybe descending, because then you see the things you launched recently at the top. This is very strange. I don't know what this bug is. It's probably something silly, but I guess we'll have to work out what's going on. Okay, so sorting proxy model, the way that it works is that it just acts as a proxy in between your view and the model that you want to access. So you install a proxy model that sits between, and then it just forwards requests in both directions between the view and the target model. And then the sorting part of it is that he keeps his own internal index mapping, and then you can sort. You can tell it to sort by a specific column, and then the target model, nothing happens to the target model. So the target model just has his data the way he likes to store it, and then the sorting proxy model takes care of the reordering things so that they fit the sort order. Anyway, so we're here. So we're calling map to target for an index, and it's not working. So what's map to target do? So we can't convert this model index. So this is like row 20, column 1. I wonder why that is failing. It sounds like a perfectly valid index in this context, but it seems like it's failing for everything. Like even at the very start of the content, it's failing. So why would map to target fail? So the index is valid, sure. So here, let's say map to target, and then we can say the row that we're trying to map. Row mappings. How many mappings do we have? Column count just forwards to the target model, right? So we have 0 row mappings. That's probably why it doesn't work. So it will do an mTarget on update resort. Presumably we're not doing a resort. Oh, wait, I know what's going on. I am not calling did update model in my running processes model. That's why. When you perform an update, it is your duty to call did update. That's right. And then we don't need any of the things in libGUI, so we can just remove that debug stuff. It's good that I'm using the model view stuff a bit, because lately I'm thinking more and more about re-architecting it and doing it differently, because it does not feel super intuitive the way that it's currently set up. And null here, we gotta get rid of null. I think we should do either an empty icon or an empty string. We can do an empty icon maybe. We don't want it saying null in characters. It looks very silly. All right, so this is kind of cool. Okay, so then let's say that we want to profile Windows Server, right? I can't profile it. Operation not permitted. All right, fine. So let's do browser. Oh, now it doesn't show up here. Interesting. I guess we could update that list every now and then. So browser, profile, and then we exited everything. Wonder if we actually started profiling it. Let's stop profiling it and see if we got something. No, we did not profile. Okay, so we just exited after selecting that thing. So wait, how did we do that? Profiler main. I think probably exiting that event loop there just kicked us out completely. When we did the event loop quit, then what happens is we have an exit requested. And then if exit requested, we return exit code from exec. Although this shouldn't make us exit. So why did we leave? So we did profiling enabled, that worked. And then we did an event loop quit. And then this returned, and we should be here. Okay, so let's printf. We're here. Okay. Because I feel like we're not getting there. Something here ain't right. So let's just profile the taskbar. Yeah, we didn't printf anything. We just exited. So this kills us, but why? I don't get it. Event loop pump does what? Who exits? Who exited? Application exec. Wow, this is an old comment. If you do app exec, then we don't return after. That's kind of silly. We should just return. This comment is so old, it should not matter anymore. Like, this is from way before core object was reference counted. Then there was this big issue that tearing down the whole GUI widget tree was a big nuisance because it had this magical ownership model that has been replaced completely by reference counting, which is so much nicer. So PV, and then we run it on the terminal maybe, and we are here. Right. So then the issue is that we can't, oh wait, why did that not work? I guess because we never stopped profiling. Right, so now we need to go into a mode where we are recording for a while. So profiler main, maybe we should really move this to a separate function. So static void, generate profile, create profile. Okay, so here, create profile. Or was it generate? Oopsie. And then we'll move this outstairs, which is not a real word, but it sounds cool. Outstairs. We'll move this downstairs or outstairs or whatever. Yeah, so we'll call that, and then if that fails, then we will just return here, yeah. And we'll give him a chance to return an error code like that. All right, so return app exec, or maybe we'll have a Boolean somewhere. Bool success is false, let's say, and then success is true. For event, actually here we can do app quit. Oh, we can't see the application object here. Dang it. Well, it has a singleton getter, so that's okay. GUI application the quit. Ha. So then return app exec is 0. Ha. Double ha. All right. So then what we want to do is we want to show some kind of UI that just says like, oh, you've been recording for this long, and then give you a chance to stop recording maybe, and maybe it will time out say after 5 seconds, because we have a limitation in the kernel right now. I think if you record more than 7 or 8 seconds, things will just fall apart. So we can have like a little workaround for that issue as well until we actually go and deal with it in the kernel. So this will be the, we can split this up into a few things. Or actually this is, again, this is like step 1 prompt for process. Process to profile. So that's this whole step right here that we just did. If that doesn't work out, then return false. Otherwise, now we will show a window. Yeah, so prompt for profiling, prompt to stop profiling, I guess. And then we'll return true eventually. Because after you've stopped profiling, then you should be able to load the profile. So now we will do this whole thing again. This code is really strange looking, I have to say, but there's something old school and kind of adorable about it, so I'm not complaining. So here what we'll do is we'll have a smaller window, maybe like a littler one that's like 320 by 200, and maybe we'll just show like a clock that's ticking up how long you've been doing this or something like that. So I'll just put a label, GUI label, timer label, and we'll just put that, start it out with some text like that, I don't know, whatever. And then we'll make a timer, so core timer, oh, we need core timer. Core timer, create. Every 100 milliseconds, we will it's not create, it's construct, right? Every 100 milliseconds, we will call timer label update. And we need GUI label, apparently, we forgot that. Okay, so we'll update the label. And actually, we don't need to update, we can just set text on it. Set text string format. %G, and then we'll put like elapsed timer. You can call it like clock. I don't know, just something. And we need elapsed timer. Clock start. Maybe we'll call this one update timer. So then we'll just set the clock elapsed divided by 1,000 because it's in milliseconds. All right. And maybe we'll also put a button. This is not going to be very beautiful, but it'll be okay. Stop. Okay, so we'll say like profiling. Stop button on click. Core. No, GUI application. The quit. Right. And then here GUI application exec. Oof. Okay. Window show. I don't know how I feel about this one. This is a goofy UI, but gotta start somewhere. I am forgetting the auto here again. Okay, so we'll profile the terminal. And that thing is not updating very much. And we stop, and we actually got some samples. So that's awesome. This didn't work out because we construct this. Wait, why would this not work? Timer label set text. Set text. It will update. Why doesn't it run? Interval, timeout handler. Oops. Let's just print out clock elapsed every time the timer fires so we can at least see that something is happening. This is pretty cool, by the way. So let's profile the profiler. Okay, so this thing is actually doing something. It's just not updating correctly here. I'm calling timer label set text. I'm doing clock elapsed. Oh, wait. Am I a stupid idiot? Yes, I'm a stupid idiot. That was a stupid mistake. Okay, now we got our full seconds. I was hoping for something. Wait, why is it like that? Do we not support this, or? Oh, wait. Is the label... Timer label set... No, it should be the right width. Why? I'm confused. This is so confusing to me right now. Why am I failing to brain this? Am I doing something really stupid? Let's just double verify. 1500 divided by 1000. Oh, thanks a lot, Python. Right. What do we normally do for these? We do %G, don't we? %G. Yeah, sure. So if it's G, then we do print double. It's print double, we will compute the fractions. Big brain number is I mean, the float literal has to be fine, but let's also dump it out. Okay, so it's showing up correctly here. It's just not correct on the frickin' label. Huh? So what does this do then? Also, why does it think I'm in kernel mode? There we go. So what do you do for floats, you jerk? .4f. Oh, really? Okay, that doesn't seem like a good behavior, but fine, whatever. So we'll do like .1f. All right, that's not super great. Maybe we could even say seconds. Okay, so we'll profile browser, and of course that doesn't reload. Okay, so select the browser from the list. That's profiling. You can do la 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 la, and then you stop, and it brings up the thing. Okay, so definitely some interesting progress happening. I'm liking it. It has its quirks for sure, but it is also progress. So let's see that it works the old way still. So profile id. Yes, this just works. So this is strictly new functionality. So let's just commit this, and we'll also commit the application change. Make application exec return instead of calling exit. We were calling exit here because we didn't want to deal with object teardown in the long ago. Before core object had what was reference counted. Ref counted. Okay. And then there. Profiler. If run without arguments, allow user to select, let user select a process list. Select process. Now show a list of running processes that the user can choose from. After choosing one, we start profiling it and show a timer of how long, show a counter of how many seconds, show a timer, a stop button that the user has to press to stop profiling. I guess that's okay for now. Maybe we don't. Maybe we should have that auto stop thing. I don't know. Anyway, we should. I wanted to have this available from the system monitor. So let's see. We had kill process in that menu. Right, so we have kill process, stop process, continue process. Wouldn't it be cool if we also had profile process? Now we're talking. Maybe you would just press Control P and it would profile that thing. Pretty cool. I don't have a good icon for this right now, so that's something we'll have to invent in the future. But essentially, this will be our action, and then instead of doing a kill, what we'll do is we want to launch the profiler. I think, should we POSIX spawn it? I have to get a cheat sheet for POSIX spawn, okay. So we'll get profiler. And then here we want to provide the PID. So maybe we'll say something like --PID. And PID, something like that. PID string, all right. Dot characters. And oh wait, where did I need that thing, right? And I guess if this fails, then we could say something about it, like error, POSIX spawn. And oh, do I need to include something for that? Include spawn. It's my first time in my whole life calling POSIX spawn. There we go. Okay, so then we need the profiler application to accept PID argument. So let's grab an args parser. Okay, so args parser, add option. Wait, how does this work? Add option PID to profile, PID P. Wait, how does this? I have to ask it. How do I know if I have that thing? Let's see, found option, blah, 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 requires m, blah, 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 accept value, blah, blah, blah. Wait, can we provide this? I mean, I guess if the PID is non-zero, right? So we don't have to get fancy here. So we'll just do something like, yeah, we'll just leave it like this. And then we'll say if profile PID specified PID if there's a specified PID, then we don't need to get a PID. We just need to, so okay, let's separate this out. If specified PID is 0, then we'll do specified PID is this. And if we still don't have one, then fail. Okay, and then we will start profiling the PID that we have, so we'll have to move that out. Down here. Okay. And then we'll fail like that. We should just call it PID. All right. That's probably fine. Maybe it's fine that we exit too if you select something we can't profile. I don't know. Maybe that's annoying. No, let's do it this way. Okay, so we get the PID and then we just need to return it. So success here becomes PID starting out with 0, and then stash it here, quit, and run the event loop, and then turn PID. Yes, like that. Okay. Hello? Okay. So that's fine. Let's bring this up. And oopsie doopsie. Oh, it's not in the menu. Oh, I didn't add it to any menus. Dang it. Okay, that's my bad. Continue action. We need to add it to some menus. So maybe we'll put a separator even. And we'll add it to the context menu as well. Okay, so say that I am here and I want to profile my system monitor. Copy pasting is bad for me. I need to not copy paste so much. Oh man, what a stupid bug. Okay. All right, come on now. Okay. Bloop. And something crashed. Oh, because we didn't pledge exec? Yes, has not pledged exec. Okay, well, system monitor can be allowed to exec a single binary. So we'll add exec to his pledges, but we will only let him exec, bin profiler. So he'll be allowed to start the profiler, but nothing else. Okay. Well, that's not quite exactly what I wanted. So did I forget to call parse on the args parser? Yes, I did. Dang it. Exit on failure. Let's say false here. I need to get a bit better at using the args parser, I feel like. profile. Okay. Oh, it should say what PID we're profiling maybe. But I think this is it. Yeah, it looks like it. It's a bit of an uninteresting profile, but let's try this with something more typical. So like, say that I open a GitHub page for Serenity, which tends to be pretty heavy on activity. Now it's very heavy in protocol server, which I can't actually profile because it's not mine. But now we're in browser. So okay, so here I would profile browser and record for a while and then stop. And it works. That is so cool. That's really, really nice. Okay. So say that I wanted to profile something else now. This timer is a little bit not the happiest camper. I think the system is under extreme pressure because of... I actually don't know. I guess we can see here what it was doing. What are you doing so much? Something in the kernel. Oh, right. So we can't see kernel symbols when we're doing this because we are not super user. So if you had been running the system monitor as a super user, you would get a super user profiler, which would see kernel symbols. But now you just get this mystery symbol instead. But maybe that's fine. What the heck are we writing to here? Parser print errors. Oh shit. It's all parser errors? Huh. Where do they go? I guess they go on std out, which is God knows where std out is for that process. Well, we could probably do better here. Like, we don't need to, since you can't see it anyway, maybe we should not so aggressively write to stdr or std out, whatever. Stdr, I guess. Print errors. Okay, well, let's not get sidetracked. Profiling is very interesting. Need to do some work on the GitHub support in the browser. After they changed the website layout, like we had not good, but like you could navigate the website in the browser before, but then they changed the layout and they used a bunch of new features that we don't support yet. So some work to do here. Still, this is very, very, very nifty. So let's just try with a super user system monitor. So we can profile whatever we like. So let's profile Windows Server. And I do some stuff like that. And look at that. We can see kernel symbols and everything. Very, very nice. This is some good stuff. Now, the UI is obviously not super beautiful. And did I commit with we're here? Did I really? I did. All right, well, we're gonna take that out. The UI is not beautiful for sure, but I think it's a good start. And I like this thing here where you can like select one of the currently running programs and connect to the clock menu applet up here, for example, and profile that for a while. He doesn't do much. Once every second he will update himself. But evidently that does use some CPU cycles. So wait a minute. Why do you have a scroll bar paint event? Wait a minute. Spin box. Scroll bar. Sin H. There's something that does not quite add up here. These are a little bit nonsense. I wonder why we're getting nonsense. I was not getting nonsense for everything, only in that clock menu applet. Let's try the terminal app. Terminal widget stuff. Yeah, okay. So I guess we just saw some kind of a goofy bug there. It's not like the system doesn't have goofy bugs, but I like this progress that we made here. So I think we're gonna wrap it up with some commits. So here, let's see. Let's remove that guy. So we'll commit this. Oh, my cat wants to come in. I'm going to let you in a little bit, just a moment, dude. So profiler, allow specifying a PID profile with --PID. System monitor. Add profile process context menu action. Can now start profiling a process directly from system monitor. This is really neat. This is really neat. And yeah, so the UI is going to need some work, but I'm not in the right mood for UI tweaking at this very moment, so we're going to skip that. But the feature is cool, I think, and we can keep building on top of it to do more interesting things. So I think this is going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out, and I hope that you saw something interesting today. And I hope to see you next time.